Association rule mining is a technique for discovering interesting and useful patterns in large datasets, such as the relationships between items purchased by customers in a supermarket. Such patterns can help in making decisions about marketing, pricing, product placement, and recommendation systems. However, finding association rules in a large and complex dataset is not an easy task, as it requires searching through a huge space of possible combinations of items and evaluating their relevance and significance. Therefore, efficient and effective algorithms are needed to perform this task. One of the most influential and widely used algorithms for association rule mining is the Apriori algorithm, which was proposed by Rakesh Agrawal and Ramakrishnan Srikant in 1994. The Apriori algorithm is based on the idea of frequent item sets, which are sets of items that appear together in a minimum number of transactions in the dataset. The algorithm assumes that any subset of a frequent item set is also frequent, and any superset of an infrequent item set is also infrequent. This property, known as the a priori property or the downward closure property, allows the algorithm to reduce the search space by pruning candidates that are not frequent. The a priori algorithm works in an iterative manner, starting from frequent item sets of size 1, single items, and extending them to larger and larger item sets as long as they are frequent. The algorithm consists of two main steps: join and prune. In the join step, the algorithm generates candidate item sets of size k by combining frequent item sets of size k1. In the prune step, the algorithm eliminates candidates that have an infrequent subset, using the a priori property. Then, the algorithm scans the dataset to count the support frequency of each candidate, and retains only those that meet a minimum support threshold. The algorithm repeats this process until no more frequent item sets can be found. The a priori algorithm has several advantages and disadvantages. On the positive side, the algorithm is simple, intuitive, and easy to implement. It can handle large datasets efficiently by using a hash tree structure to store and count candidates. It can also generate association rules from the frequent item sets by computing their confidence, conditional probability, and selecting those that meet a minimum confidence threshold. On the negative side, the algorithm can generate a large number of candidates, especially when the dataset has many items and transactions. It can also be slow when the minimum support threshold is low or when the dataset is sparse, has few frequent item sets. Moreover, the algorithm is sensitive to the choice of parameters, minimum support and confidence, which can affect the quality and quantity of the results. The a priori algorithm has had a significant impact on the field of AI, as it has inspired many extensions and variations to address its limitations and to adapt it to different domains and applications. Some examples are FP growth. This is an algorithm that avoids generating candidates by using a compact data structure called a frequent pattern tree. FP tree, to store the frequent item sets VCLAT. This is an algorithm that uses a vertical data format, transaction ID lists, instead of a horizontal data format, item lists, to represent the dataset and to count the support of candidates a priori TID. This is an algorithm that uses a reduced database, containing only transactions that have frequent items, to speed up the counting process. A priori inverse. This is an algorithm that mines rare item sets, infrequent item sets, instead of frequent item sets by using a maximum support threshold instead of a minimum support threshold. A priori-based algorithms for other types of data. These are algorithms that extend or modify the a priori algorithm to handle data that are not transactional, such as sequential data, example, DNA sequences, spatial data, example, geographic locations. Temporal data, example, time series, or graph data, example, social networks. To sum up, the a priori algorithm is a historical and impactful approach for association rule mining that has contributed to advancing our knowledge and understanding of large and complex datasets. It has also stimulated further research and innovation in developing new and improved algorithms for finding patterns and rules in various types of data.